Thank you, Volker. Thank you very much for the invitation. Very kind. Thank you, everyone, for coming today. So what I'm going to present is still work in progress. So obviously, all your questions and feedback is more than welcome. And of course, I'll be speaking in my personal capacity for this research. So let me try to explain what this strange title is about. So a bit of motivation. How did it come to this idea of intertwined effects? Well, actually, I came to this idea of this paper. I was looking to buy a phone, and I tried Google Shopping, which I was not very used to. Type. Well, obviously, I didn't type phone, but for the sake of example, let's just put phone. And I noticed something interesting when you go to Google Shopping, which is a marketplace. You can find sellers like Samsung there, but you can also find other competing platforms that are also marketplaces trying to sell you the same thing from sellers, like Amazon.com or Media Market in Spain. So I thought that's interesting. Why would Google Shopping try to send you to a competitor that is trying to also uh, compete as an intermediator in a marketplace? And I thought that sounds weird. And my first instinct as a competition economist is to think, oh, this is some sort of competition softening. When you see collaboration between competitors. So I tried to sketch what was going on here. So I tried to do a sketch of a model to see what's going on. And this is what the paper is going to be about. You see, this slide kind of summarizes the main idea. So if you take this running example, we have Google Shopping, which I will call the aggregator platform, which is a platform that intermediates between two sides. Let's call them buyers and sellers. And the two sides benefit from having other people on board. And then you have another competing platform that I will call the source platform. In my running example, that would be Amazon Marketplace, which does the same thing. And what you see in green is the tweak on the core of his paper is what it is about. It's this idea of intertwined effects. Why intertwine? The idea is that, well, if you're a buyer in the aggregator platform, you can access the sellers in the source platform, but not the other way around. So the sellers in the aggregator platform cannot access the buyers in the source platform. So if you're on Google Shopping, you can see also the sellers from Amazon. So in a way, Google Shopping is better because it gives you more options. But if you're a buyer in Amazon, you cannot see the sellers on Google Shopping. That's why I call it intertwiner effects of this, like the image for what I call. So this idea of cross-platform network effects, they're asymmetrical. Asymmetrical in the sense that it doesn't go both ways. As you see here, there's only diagonal arrows in one ways. The sellers of the aggregator cannot see the buyers of the source platform. So I thought, okay, that's interesting, but is this a thing or is it just one example? And well, I realized that it's actually more pervasive than I thought initially. So you have Google Shopping, you also have Bing that has a similar shopping tool. You see it a lot in price comparison sites, that would take you to marketplaces, but they will work as marketplaces themselves as well. So you have the same idea, Also, a lot in the travel industry, like Trivago, for example, that you can get a hotel on Trivago, or Trivago can take you to Booking.com, a competitor of Trivago. That's the same thing. It intermediates between hotels and people who want to find hotels. In real estate, actually, when I started thinking of this, it's like, well, actually, you see a lot of many countries, at least in Spain, we have it. But when you go to a website to find a house, many times you would see listed a real estate agency. Well, a real estate agency is a brick and mortar platform. So again, you have a platform that is sending its buyers to a competitor platform, but not the other way around. And then, perhaps also more interesting in terms of policy, there's a lot of merger cases that happened. So here I tried to put them all across the world, mostly in Europe, of platforms that actually set up interplanar effects after the merger, or said they would. Some went through, some didn't go through. But this is just to show you, it's actually quite pervasive, and many of these platforms are the leader platforms in their countries. And another interesting thing to notice here is most of the times these platforms are horizontally differentiated. So, for example, eBay, you all know eBay, I guess. It's a generalist marketplace for second-hand stuff mostly. they bought Motors.com UK, which is a marketplace for cars exclusively, or StubHub, which is to resell tickets. So they're same type of platforms, but usually you see the pattern that the aggregator tends to be a wider platform, and the other ones are more specialized. So what I'm going to try to answer to today, is well, first is why. Why would competing platforms set up intertwined network effects? Why would you help a competitor? Is this some competition softening? Am I getting ripped off when I go to Google Shopping because of this arrangement? The second question I'm going to try to answer is, well, what's the effect of all this? Who's winning? Who's losing in terms of consumer surplus or surplus? What happens with participation prices? What's the effect you should expect of this? And then what happens when there's a merger? So I will not talk about the merger today because we don't have so much time and paper is getting long already. So I'm going to focus on intertwined network effects without the merger, and obviously we can talk about it afterwards. I have some slides for later if someone is interested. So very quickly, in terms of related literature, this paper, well, it's in between, I would say, three strands of literature. One on, perhaps the closest is there two papers that have this idea of hosting or referring to rivals. Lambin has one that asks a very similar question, but actually focus on newspapers, online newspapers. So the setting is quite different, and hence the results are different. There's also Hague and co-authors that have a similar idea of hosting a rival, but actually not a platform paper. So it's actually their paper tricks to explain why endogenously a platform might emerge from this idea of hosting a rival. So these are two papers that pose similar questions, but in very different settings. So I would say they're quite complementary to this broader research question of this intertwined network effects in my parlance. And then you have papers on interoperability between platforms, especially the strand that talks about interoperability between platforms with indirect network effects like here, because you also have the older literature on fax machines or telephone networks, or more about direct network effects. And as you will see in a second, that the modeling resembles a lot of that interoperability literature. And there's particularly one, the Maruyama and Senio paper, that has this asymmetric case, although again in a very different setting. And then the literature on non-consolidating platform mergers between platforms are doing the same, so horizontal mergers. So I will walk you very quickly through the model. So just try to show you the let's say the main equations, the primitives, and that's it. And then I walk you through the intuition just to show you how I'm trying to think about this and perhaps show where the novelty I think is. So first, what are the main ingredients of the model? Is well, first going to be a competitive model, bottleneck model. So consumers single home and sellers multi-home, or can multi-home if you want, which is we have empirical evidence that sellers multi-home a lot in these platforms, the ones that I'm interested in, you see in all the icons. And sellers tend to prefer one. And also, as you will see a little bit later, that makes it more rational for intertwined network effects to exist. Otherwise, everybody would multi-home and they wouldn't actually need to be redirected anywhere because everybody will be always checking all the platforms, right? So that's why competitive bottleneck seems the most appropriate way to model this. Then, as I said before, many of these platforms are horizontally differentiated, both for sellers and for buyers. And therefore, I'm going to add this dimension to the model. Another interesting ingredient, for the sake of realism, but also gave me a lot of pain in solving the model, is the idea of a per transaction price, right? Like you see a lot of these platform models are usually have like just an entry price to the platform. But in these cases, these transaction platforms, mostly marketplaces of different sorts, usually the business model is a per transaction price. So for every time you click on a link or every time you contact a seller, the platform gets a commission. And finally, an endogenous referral fee. A referral fee is the fee that a platform pays to another platform for getting traffic from them. So in the running example, Amazon would pay a certain amount of cents per click that a person did in Google Shopping and took them to Amazon. And this is going to be determined endogenously in the model. And you will see in a second that's actually going to play an important role in the results. So how am I trying to think about this model? What you have here is, say, the three basic equations of the utility of a players. So it's a very standard platform model, but with certain tweaks, and the tweaks you can see highlighted in green and in blue. So for users, you have two platforms, platform 0 and platform 1. Platform 0 is the aggregator, so that platform would be, in the running example, Google Shopping, and then you have platform 1, which is the source platform. Again, in the run example, that would be the Amazon, the one that gets the traffic from users. So users have a standalone utility, this is BB, and then they have this alpha B, so that's the strength of network effects for them. That depends on the amount of sellers that are on that platform, platform 0, plus, and that's the first green part, on the amount of sellers on the rival platform. Because remember, if you're on Google Shopping, you can also see the sellers of Amazon. So the more sellers are on Amazon, the more useful Google Shopping becomes to you. So here is the first, let's say, intertwined side, right? Minus the transportation cost it shows. But for the other platform, we have a very standard equation where just your network effects depend solely on the number of sellers on that platform. You're on Amazon, you only care about Amazon sellers because you cannot see the sellers from Google. And users don't pay the fee. It's going to be the sellers who pay the fee. It's mostly the case in these marketplaces. So on the seller side, you have the kind of like the reverse. So in the aggregator platform, the sellers in Google Shopping, they would care about the number of buyers there. They would pay a price, P0, for every interaction with them, minus transportation costs. But for the sellers of the source platform, so the sellers of Amazon Shopping in my running example, you can see the sellers care about the total number of buyers in both platforms, minus transportation cost, minus a price they pay per interaction, that P1S. And finally, what happens with platforms? Well, also their business model is going to change a little bit. If you're the aggregator platform, if you're Google, you're going to make money traditionally through the number of interactions. So that's the number of buyers times the number of sellers, assuming for simplicity as many as it models that you got one interaction per pair. And plus, they're going to get also a referral fee for every interaction between their buyers and the sellers of the source platform. And conversely, on the side of the source platform, they're going to get traditionally money from every interaction between their sellers and their buyers. But they're also going to get now money for every interaction concluded between buyers of the other platform and their sellers. But for those, they would have to pay the fee. That's why you see a minus F. So they're going to have to pay a commission, that referral fee, to Google for having sent them. And the timing is going to be classic timing. First, the platform 0, so that's the aggregator, will set the referral fee, say how much I charge you to send you sellers. Then the two platforms are going to simultaneously set the prices they want to charge to sellers, and then consumers and sellers will simultaneously choose which platforms to join. And remember, the sellers can multi-home, buyers don't, they single home. So what are the results in terms of what is the effect of intertwined network effects in this theoretical setting? Oh, first, this gives a first answer to why do platforms actually set these intertwined network effects? There's two reasons. First, it increases the matching quality. Even if it doesn't lead to more transactions, you find a better hotel if you have more options. That's it. Yeah, and the hotel is more likely to find a buyer, or a buyer that pays more, a buyer that wants that type of hotel if he has more options. But you can also think it leads to more transactions, which actually makes sense for multi-product platforms, especially if these are very differentiated, right? So you go to eBay to buy a second-hand coffee machine, but you end up buying a ticket because you see a link to StubHub. Yeah? That's the idea. So that's why it creates new surplus. It creates transactions that wouldn't have happened. And actually, when you check, under which conditions it appears, that's the little graph you have there in the parameter space. Basically, what you see is that unless the platforms are very homogeneous, and which again shows the importance of having horizontal differentiation, there are conditions for intertwined network effects to appear. So as you see, most of the cases in which there will be an equilibrium from traditional competition, there would also be an equilibrium for intertwined network effects. So perhaps more interesting is that platforms, whenever they can choose, they always prefer intertwined network effects. And the intuition here is that, well, it creates a new surplus, and because of its referral fee, the platforms can divide this new surplus. So what happens, what are the effects on the number of buyers and sellers of intertwined network effects? So let's try to reason, let's see the effects of a model. So here I'm comparing and solving the model in a baseline where you don't have intertwined network effects, so all those terms that I put there in colors disappear, versus a model in which you see the equations I showed you before with all the terms in color. So basically, you see what is the effect of adding these intertwined network effects. So if so, let's start with the buyers. Well, a quite intuitive outcome first is that there's going to be more buyers in the aggregator and less buyers in the source platform. So now that Google Shopping allows you to see sellers from many platforms, well, it becomes more valuable because you have more options there. So some buyers are going to migrate from the source platform to the aggregator platform. And then that's going to have a knock-on effect on the price paid by sellers. So let's focus first on the source platform, the Amazon. Well, the price they charge to sellers is going to increase for two reasons. First, because the quality of what they're offering to these sellers is increasing. The sellers on Amazon now can access also the Google buyers. So they're going to raise the price because the quality goes up. And also because the marginal cost increases. Now they have to pay a fee for every interaction that comes from Google, from the aggregator. So that's also a reason why they would increase the price. When you go to the aggregator, it depends whether the price is going to go up or down. And this is basically depending on how mobile the buyers are. So how homogeneous the platforms are substitutable there to buyers. So if platforms are very substitutable, if they're very similar to buyers, then what's going to happen is that a lot of buyers are going to go to the aggregator once you introduce intertwined network effects, and hence the platform is going to try to take advantage of that and raise the prices to sellers because the quality is increasing a lot. But if the platforms are very differentiated and just a few buyers go to the aggregator platform, well, then actually the aggregator platform is going to do the opposite. It's going to lower prices to attract more sellers because this new buyers is not enough, and actually try to make more money out of the referral fee because now it has another source of revenue. So okay, maybe I lose money on what I charge sellers for each transaction, but I'm going to have more sellers and I can monetize the transactions I say to my rival. So it will depend on that. And finally, what happens to sellers is that the number of sellers will increase in the aggregator platform, basically because even in the case when they increase the prices, they're always better off. They always get more utility per buyer. And in the case of the source platform, it's going to go down because basically you have less buyers and a higher price. So sellers are always worse off there. And the total amount of sellers would depend on what happens with multi-homing. So here again, it's going to depend on how mobile the buyers are. So if the buyers are not very mobile, so if the transportation costs are very high, it's going to be increasing multi-homing, basically because the prices in the aggregator are going to go down by a lot. So many sellers are going to switch from single homing in the source platform to also start multi-homing in the aggregator platform. And otherwise, it will go down. So that's for quantities and prices. And then what does it imply for consumer surplus? Well, in the aggregate, consumer surplus is always going to go up, basically because consumers in the aggregator get access to both platform sellers, whereas consumers in the source platform, they lose access to some of the platform sellers. Some are going to migrate. So in the net effect, it's always going to be positive, although the buyers in the source platform is always going to be worse off. And for sellers, whether they're going to be in the aggregated worse off or better off will depend on how captive they are, how horizontally differentiated platforms are to sellers. So that's the transportation kind of sellers. So the intuition here is that if enough sellers switch from multi-homing to single homing in the aggregator, the seller surplus increases. So the idea here is that now this platform, the aggregator, is more attractive than before for sellers. So the net utility always goes up for them, even in the case when they raise prices. And for the search platform, it's less attractive to sellers once you introduce intertwined network effects. So it's a matter of how many switch. Yeah. So if a lot of them switch to the platform where they're better off, and that's going to happen if transportation costs are low, then there's going to be an overall increase in seller surplus, even though those in the source platform are worse off all the time, and vice versa. So that's the idea of what should happen with intertwined network effects. And then, well, once we have these nice results, and again, skipping the part of mergers, try to ask myself, okay, can we actually check these results empirically? Would there be a way to see if the model prediction hold? And I'm gonna try to do that. I'm still working on it. And that's the part that is still more under work, but I already have some interesting results. So I'm gonna look at data, two sources of data. The first one is Sensor Tower. Sensor Tower is an app subscription that gives you analytics about app usages. So how many people use each app you can find in the Android and iOS stores on smartphones and tablets. And it has data from October 25 to today. Here, the metric I'm interested in is weekly active users. So that tells you for a certain app in a given country, in a given week, I'm going to stick to weekly observations to smooth out all the noise you can see in between days changes in app usage. People use certain apps more on Sundays and so on. And I'm going to try to look at how many users each app has. So importantly, this does not distinguish between a user as a seller or a user as a buyer. And as you will see in a second, in my cases, also this distinction is blurred because these are mostly classify ads platforms, where you can be the seller of use a coffee machine, and you can be the buyer of a couch tomorrow or the same day, actually. So here I have a metric of buyers and sellers all together, right? But that's okay, because if you remember from a few slides ago, the prediction is that in the aggregator, the number of buyers and the number of sellers should go up, and in the source platform, the number of buyers and the number of sellers should go down. So in the aggregate, it should go up or down. And this is, you can think of this as an extensive margin metric, in the sense that it tells you how many new distinct devices connected to an app, but it doesn't tell you what they do in there, if they spend too much time, if they buy stuff. So that's why I call it an extensive margin metric. My second metric is going to be an intensive margin metric of seller participation. So here I'm going to look at the number of listings that these platforms have. In the cases I'm going to present in a second, it's always listing platforms, classify ads, like this one here, one of the platforms to study, adverts. So basically, what you see here is, they say we have 688,034 listings today. So here, what I did is that I used the Wayback Machine that many of you must know. This is a website that stores snippets of like what web pages look like. They keep the HTML code of every website in their internet through time. Obviously, it's not a constant thing where you have an observation per day. It may be sometimes random, but you have enough to make weekly observations. So if you web scrape that website, you can reconstruct. This is an example for one day. I can web scrape that number and make a database, and that gives me a time series of a number of listings of platforms. So with these two metrics, I'm going to try to test the predictions in two cases. The two cases that I could find, and that actually have an explicit date where they introduce intertwined network effects, so I can measure the effect after the introduction versus before the introduction. So the first case is Adverts and DoneDeal. These are two platforms from Ireland, active in Ireland, only active in Ireland. Adverts is a generalist classified platform, so where people sell secondhand stuff. And DoneDeal is the same, but for cars. And it has mostly cars and agricultural listings. So again, this idea of differentiation between the platforms. These two platforms merged first in July 15. And then 2 years later, in December 2017, and importantly only in Ireland, because they're only active in Ireland, they decided to do this thing that I put in the snippet they put in the website, is that if you go to adverts, you see less than 10 results for certain queries, they will put you automatically for listings from the other platform, DoneDeal. So in this case, it would be obviously motor vehicles. So, if you're looking for a car in AdVerts and there are too few results, they'll put you, a link from this ad that comes from another platform. You click and you go to it. So, this is a perfect timing introduction that I can try to exploit to see what are the effects. So I'm going to try to see what are the effects in every case in the two metrics. So buyers plus seller extensive margin, how many new users overall, and intensive margin, what happens with the number of listings. Well, let's look at the descriptives first. What you see to the left in blue, DoneDeal, that's the source platform. And you see it compared to what's going to be my controls. My controls are going to be, in each case, the same app. In other countries, the other countries are Great Britain and the US. These are the two countries in which they have users, but the app is not active. So those users cannot enjoy the intertwined effects, but there might be people that use this app on less regular basis when they go to Ireland. And so I'm going to use those as control. As you see, they move quite similarly before the introduction of intertwined effects. In the case of DoneDeal, you don't see much of a change between the two trends. But in the case of AdVerts, the aggregator, where you would expect the prediction to say that buyers and sellers, so this is my metric, goes up, you do see quite a break in the tendency that goes up, while the users in the other countries of the same app continues going down. So here, what I did is basically an event study of this case, and the event study confirms what you would expect from this descriptive. So when you control, obviously for this case for platform country and weak fixed effects, you still see that AdVerts, the aggregator, increased quite in a steady upward way. So with an increasing effect over time, that goes up to 6 standard deviations pre-introduction of intertwined effects in the number of total users, buyers plus sellers, so weekly active users. For DoneDeal, nothing much happens. So this might be the case, assuming the model holds, it could be because the channel is actually the intensive margin, or another option in the model, it would be like the platforms are too differentiated and therefore nothing happens. If these TS or TBs are too big, you should expect not effect. But I'm inclined to think it's the first, and this is still work in progress, because when you check out the listings, so far I only have descriptives, you do see a change in pattern in the case of DoneDeal. So for AdVerts, this is the number of listings. When I show you the little excerpt from the Wayback Machine, you see the number of listings, you reconstruct this database, and you see, well, first for AdVerts, the aggregator, there's an upward tendency overall, but this is very cyclical, because at the end of the year, then they tend to, listings tend to drop and then things go up. These are very seasonal type of platforms. And what I did here is that for each of them, because of this intra-year seasonality with a trend over time, I fit an asymmetric square root function that actually describes very well this type of patterns before the introduction of intertwined effects. So I fit it to before to see what is the trend that you see up to the introduction of intertwined effects. And then let's compare what actually happens with the listings. So that's the normal, the full line, versus what happens in the pre-intertwined effects tendency. That's the dotted line. And what you see is, mostly the AdVerts is trending upwards versus its mean. So it shows that it's up from the tendency. So you would expect that the number of listings is higher than you would expect from the previous tendency, which indicates, again, no causal effect here yet. I'm trying to work on that. But at least from a descriptive point of view, you do see support for the idea that there are more listings than you would expect. And for DoneDeal, so same thing, same type of asymmetric square root fit. And here you do see, again, a tendency that is indicative of a break in the pattern. So you do see that after intertwined effects, the number of listings drops below what you would expect from the previous tendency. And there is a second case where I try to do the same thing with the other case I could find for where they have a specific date that you can exploit. This is Finn and Nettbil. These are Norwegian platforms. So Finn is again a generalist classified aggregator platform. And then you have Nettbil, which is a car selling platform. And in the case of cars, they have very different policies. So in Finn, it's the individual who deals with the wholesale. You contact the person, you sell the car, you do your thing. Whereas in Nettbil is more special because in Nettbil, you basically give the car to Nettbil and they do an auction and sell it to car dealers, which in turn will sell to people. So let's say from the perspective of the seller, is a different process than the seller of a car, right? For the it's different. So same type of story. First, they merged in 2019, and 1 year later, in December 2020, they introduced intertwined network effects. And how did they do it? You see it in the screenshot. If you go to their website, you have, oh, this is Norwegian. Not if very Norwegian-speaking people around, but from what I could get from Google Translate and the little icons. So these are the categories they have, right? So you can shop for furniture, you can shop for jobs. They do all sorts of classifieds, and they introduce this icon that says Nettbil. If you want to buy a car, now they take you to their other platform. And again, only in Norway, right? Because these are platforms are Norwegian. But again, they're used by people who live in nearby countries. So what happens here? Again, descriptives, what you see. In this case, I used as a control another app that seemed to follow parallel trends. That's called Blocket. Does the same thing. It's also a popular Norwegian classify ads platform. That's the orange. And they're owned by the same parent company. So I think that also explains why you see similar patterns compared when I tried other competing platforms owned by others, which is actually good, because it allows to control for a lot of things. And here, what I'm also going to use as control is other nearby countries where people might, again, from time to time use this app, but they cannot benefit from, especially from the car part, which is what it brings into Intertwined effects, because it's weird that you would buy a car in a country where you don't live. And these are going to be Denmark, Finland, and Sweden. So what you see in blue is the platform of interest, which is Finn. For Nettbil, they have no app, and they don't put the number of listings, so I cannot observe anything. So here I can only test for the aggregator. And in orange, what you have is Blocket, the control, and in shaded, you have the same app, but for the control countries. So, for Norway and strong, and when it's shaded, it's the other Nordic countries. And again, you do see what seems to be a break from the rest, only in Finn and in Norway, which indicates that the number of buyers and sellers increases here. And when you do an event study, it's in this case, so again, the control is Blocket in all the countries, including Norway. So this is another app. And the app Finn in the control countries, so Denmark, Finland, and Sweden. I also control, like in the other case, for platform country and a week of fixed effects, and in this case for COVID restriction, because this coincides with COVID. So I was, worried that some of this is COVID specific, but I control for the stringentness of COVID. Oxford has a nice database of that. They calculate an index based on the measures they took to control for differences, how stringent it was to use to go out and in these countries. What you see here is a clear jump about 11 weeks after the introduction of intertwined network effects. That it seems to be quite a discrete jump that it stays more or less around one standard deviation of the number of weekly active users afterwards the introduction of intertwined network effects. In reality, it might have been less stark, so this might be also because of how the sensor tower measures the number of users. So it might have been, let's say, smoother than that, but the important thing, what you see here, is that indeed there seems to be, again, a causal effect on the introduction of intertwined network effects on the number of weekly active users as of the aggregator platform, as the theory would predict. Still working on the listings part for this one. And I hope I can bring next time more insights on that, and especially if I can find some good control grips. So I try to summarize here to leave some time for the discussion with some 3 conclusions, 3 takeaways from this. Well, the first one is that I think I was wrong at the beginning with my intuition that there was some sort of competition softening, that is intertwined network effects, some sort of shady arrangement between competitors. Actually, it's not a competition softening. They basically create new surplus. They create new interactions. And the platforms divide this new surplus with the referral fee that they set themselves. So it doesn't lead them to being to compete less for clients. Different story with the merger that I haven't talked about today. But they cannot be Pareto improving. also that's important. There's always going to be someone who loses, someone who wins. So overall, consumers should be better off because of intertwined effects. So this surplus is always good for them. You know, they get some users get access to more sellers, and since they're not paying a fee, that's good for them. But as I showed in the beginning, the consumers and the single home sellers in the source platform are always harmed by this. So they're always better off. So some of the sellers in the source platform and all the buyers in the source platform are going to be worse off. But in the aggregate, consumers are going to be better off, and sellers may be better off or worse off depending on how differentiated the platforms are. So there's always going to be winners and losers. And finally, for some policy implications of why should we care about this, a space for the geeks of industrial organization, but I think this has two very important applications. The first one is asymmetric interoperability mandates. So I'm thinking here of legislation such as the Digital Markets Act, but it could also be a lot of sectoral regulation that is asymmetric in the sense that it's imposed to only certain firms. In the case of the Digital Markets Act, only to gatekeeper firms. So far in the case of the DMA, if we stick to the DMA, this is imposed on certain gatekeeping messaging apps. So messaging apps are about direct network effects. You don't have two sides, but it is possible and totally feasible in the case of Digital Markets Act or many other of these regulations coming up that they could impose remedies or mandates of a sort of mandating interoperability between one platform that is considered too big or too important and that has indirect network effects. So this paper would tell you what you should expect from that. So I think it can inform if these policies move forward to where platforms that are subject to indirect network effects. And the second takeaway is for merger control. As I said before, there are many merger cases that have treated platforms that said either explicitly, and in some cases they tried to say it as a remedy. Oh, we're going to set up this cross-referencing. So they use different terms, but that's what in my model would be intertwined network effects. And well, I would say around half of the cases, I read all of those cases, and about half of them just don't even talk about network effects and stuff. So I think they're like, like a pre-platform theory era. And those that talk, usually they make the assumption that, oh, this is going to become one big network and everybody's going to be locked into one big network. So everyone is going to be worse off. I think here they're thinking, and that's my interpretation, these case handlers are thinking more with the models that were the most traditional ones that were about interoperability with direct network effects, and that is symmetric also. That's important. They're also thinking all the sellers are going to see all the buyers, whereas the key thing on intertwined network effects is they're asymmetric, right? So the buyers of platform A see the sellers of platform B, but not the other way around. So I think you could reach different conclusions in merger cases if you incorporate, let's say, this type of models that are about asymmetric cross-platform network effects, or what I label intertwined network effects. And you can even put them as remedies. And if they're good for consumers and you only care for consumers, and you care about consumers overall, well, actually, overall consumers are better off. So you could actually say, well, I allow the merger, but you need to redirect clients and show them X amount of offers from this other platform that you also own. So I think I'm going to stop here. Thank you, everyone, very much for your attention, and I'm happy to take questions and discuss with you in a minute. Thanks.